sometimes we can actually use similarity to figure out a particular question. Let me show you what I mean. So here I'm just given this figure with all the data as shown. So I'm told that this line PQ is parallel to this line ST. I have a few lengths here, and our job is to figure out the length of SR. We've got to figure out that length. Well, it seems like maybe we don't have enough information because, wow, I don't know a lot of stuff. I just know a couple of things here. These are parallel. How could I possibly proceed? Well, this is where the power of similar triangles come into play. If we can show these two triangles are similar, then we can set up an appropriate proportion. Well, let's take a look and see. Well, since this line is parallel to this line, I can think of this as a transversal. I know alternate interior angles are congruent, so I know that this angle right here is going to be congruent to this angle way over here. Similarly, if I look at this transversal, I see that this angle here is going to be congruent to this angle here. These two angles are vertical angles, so we know by the vertical angle theorem they're congruent. And so what do I have? I have angle, angle, angle be congruent, so therefore we know that these two triangles are similar by angle, angle, angle. Or I could, by the way, I could have just stopped with these two pairs of angles and just used angle, angle, by the way. I guess I did a little bit of overkill, but it's okay. Either way is perfectly correct. Well, since they're similar, now I can set up a proportion and actually find this length. And the way I mark my diagram is going to be handy because it's going to show me what side is proportional to which side. It might not be clear which side goes with which side, but now with those angles marked, it's very clear. I want to find SR. So SR is to, well, that's the side that's opposite the T, the double angle here. So that's going to be, is to 30 as, and then what can I look at next? I can look at the 30, which is opposite the single one, is to 25. The side opposite the single angle. So you can see actually marking the angles is very important in order to figure out which side corresponds to which side. We always are talking about corresponding sides, but in this question, we've got to actually know which side corresponds to which side. Okay, now this ratio can be simplified a little bit. Get rid of a factor of 5 here, and I can write this as 6 over 5. Okay, so now I can use the cross product idea, and I see that 5SR, 5 times SR is equal to 6 times 30, which is 180. And so when I divide, I see that SR equals 180 divided by 5, which is 36. And so I see that this length, SR, is 36. We were able to find that by first realizing, in fact, these triangles in the picture are, in fact, similar. Very cool.